Okay, so we talked about degrees and standard angles and all that stuff, but now we have to talk about the different type of angle measure, which is called radians. Before we talk about that, we have to talk about what arcs are. Arcs are portions of the circumference of a circle. Okay, so it's kind of the outer edge, just parts of that outer edge of the circle. Okay, I like to think of it as, the crust of a pizza. You have a slice of pizza, the crust is that outer part. Okay, that's our arc. Okay, so on this circle between A and B is an arc. Okay, technically the entire circle itself is an arc as well. The entire circumference can be an arc. Okay, but just 2 points between them is the arc. The arc length, as you could probably guess, is the length of that portion. Okay, if you were to straighten out that A to B portion and measure it, that would be the arc length. Okay, so it's not the direct distance between A and B, it's the entire length of that arc. Okay. So again, the distance of A to B, if you were to straighten it out, put it against a ruler or something. Okay. All right, we denote the arc length with the letter S. Okay, so that's a variable we're going to be using, or the symbol we're going to be using to denote arc length. Okay. And we're going to see this word subtends a lot. It just means opposite of. Okay. So just new word definition. Subtend means opposite. So if we draw the radii on this circle, we got the origin point from A to B, or from 0 to A and then 0 to B. The angle between them is theta. We label that as theta. And if you notice that arc AB is opposite or subtends the angle theta. Okay. So that's going to be an important part. How does that angle compare to that arc? Okay. Which brings us to radians. Okay. Radians is a different type of angle measure. Okay, so we have degrees. We know degrees, 360 degrees in a circle. Break it up into quadrants. Radians is just a different type of angle measurement. Okay. It's actually a more pure type, but a lot of people prefer degrees, especially at the beginning. All right, one thing to remember, or one key thing about radians, the definition of a radian really, is that when the arc length, so that arc between A and B, is equal to the radius. Okay, so the radius and the arc length are the same measurements. Okay, then the angle that subtends that arc length is going to be 1 radian. Okay, so again, radian is a measurement for an angle, and 1 radian is when the radius and the arc length are the same. Okay, so another way, if S, which is arc length, equals R, which is radius, then theta, your angle, is 1 radian. Okay. So visually, again, the arc length is R, the radius is the arc length, they're the same measurement. So that distance between A and B, okay, is the same as the distance between the center and the outside, okay, which automatically makes that angle that forms 1 radian. Okay, so there's not that many radian in a circle. Okay, you got 360 degrees in a circle, but 1 radian is a big chunk of that. Okay, now when you're comparing degrees to radians, 1 radian is approximately 57.2958, degrees. So it's a big chunk. There's 1 radian is almost 60 degrees. Okay, so again, you could think about there's 360 degrees in a circle. So how many radians could be in a full circle? Okay, and we'll get to that. All right, the radian measure. How do you find the radian of anything? Okay, we know if the arc length is the same as the radius, it's 1. But to find any radian measure, you do the ratio between the arc length and the radius. Okay, so if your arc length is bigger than the radius, you're going to have more than 1 radian. If it's less than the radius, you're going to have less than 1. Okay, so again, it's just arc length divided by radius. Or symbolically, it's S over R. Okay. So again, think about how fractions work. If the top's bigger than the bottom, it's going to be bigger than 1. If the top's smaller than the bottom, it's going to be less than 1. One thing to note is, we already talked about, if S equals R, if your arc length is your radius, then you set up the formula and you get S over R, which could be rewritten as R over R, and anything divided by itself is 1 radian. So that just kind of drives in that whole radian definition again. Now we are going to talk about the unit circle in a couple days. The unit circle is just a circle with a radius of 1. Okay, and it's going to be really important in the next coming weeks. So if you have your ratio, arc length over radius, but your radius is 1 in the unit circle, you're going to have S over 1, which means your angle is always going to be the arc length. Okay, so your radian measure angle is always going to be the arc length of, whatever portion you're looking at. So that's for a unit circle. And that's why we use a unit circle. It's because it's an easier measurement. All right, finally, there's the relationship between degrees and radians. Okay, so we have a half circle here. In radians, you have 1, 2, 3, and a little bit more radians in a half circle. Okay. Whereas in a degrees semicircle, you have 180 degrees. It's half of a circle. Now that little portion is about 0.14159 radians. Okay. Well, 1, 2, 3 plus that little portion, that's pi. It's pi radians. Okay. So therefore, 1 radian is equal to 180 degrees divided by pi. Okay, or 180 over pi degrees. And 1 degree is pi over 180 radians. Okay, so a half circle is pi. It's also 180 degrees. We're going to use that relationship to convert. So how do you convert from degrees to radians? Well, you take your degree measure and you multiply it by pi over 180. Okay. Now the units are important there. We got degrees on top and degrees on the bottom, and those degree units are going to cancel out. Radians doesn't really have a unit. A lot of people label it as rad. Okay. Going the other way, radians to degrees, you take your radian measure and you multiply by 180 over pi. Okay, so those are the key parts here. Now that degree symbol is not going to cross out with anything, so your leftover angle is going to be in degrees. Okay. So when you're converting to radians, the degrees cancels out. When you're converting to degrees, the degrees doesn't cancel out. All right, so those are the key points here. So we're going to show a couple examples. Really, this is just a skill in multiplying. Can you multiply and simplify fractions? That's all this is. All right, so converting radians, or 50 degrees to radians, we're going to multiply by pi over 180. Okay. Now, when we write radians, we usually leave pi in the answer. I'm going to do both here, though. So the degrees cancel out, and then you're just left with 50 times pi, 50 over pi, or 50 pi over 180. Okay, the zeros cross out. You want to try and simplify your fraction. So you're left with 5 pi over 18 radians. Okay. Now, most of the time, we'll leave it in that form. Now, we want to figure out what that measurement is. You do 5 times 3.14 divided by 180, and you get 0.87 radians. Okay, so think about remember, 1 radian was about 60 degrees, it was 57 degrees. This is less than 1 radian, which was 50. All right, going the other way, pi over 6 radians times 180 over pi to convert to degrees. The pi on top and the pi on bottom cancel out. And then it's just, you have 180 over 6. 180 over 6, 180 divided by 6 is 30 degrees. Okay. Going quick here, 160 times pi over 180. Okay. Converting this one from degrees to radians. Again, just multiply by pi over 180. That pi is going to hang out. Simplify the fraction, 160 over 180, zeros cross out. So you're left with 16 pi over 18. 16 and 18 are both even numbers. Divide that by 2. And you get 8 pi over 9. Okay. Now 160 degrees is almost 180 degrees, so this should be around 3.14. Okay. And you end up with 2.8, so that's pretty close. All right, and then finally 11 pi over 9 times 180 over pi. Again, the pi's should cancel out. That will help you remember where the pi goes. And you're left with 11 times 180, which is 1,980, divided by 9, which should be a simple 220 degrees. All right, so that's kind of the intro to radians. Now, again, the key to this, you don't really need to know how to define radians. You should, be able to visualize it. But the key for this lesson and for the homeworks is that box. How do you convert between forms?